Algebra 2 Honors, Lesson 10.5, Base E and Natural Logarithms. A common logarithm is one with base 10. A natural logarithm has base E. How do we write it? Natural log, say, of 2. It doesn't really matter. That's the equivalent of saying log base E of 2. Never done this way, ever. On the calculator, it's down here on the bottom, natural log of 2. Same as a base log of E, which, hey, I could do this. Use my change of base formula. Log base 10 of 2 divided by log base 10 of E. Should get the same thing. Whew, glad I did. Not that you needed that, just use the natural log button. So how do we solve with it? Well, first off, when you ever have an E and ln, they cancel each other. Or ln and E, they cancel each other. So e to the ln of 7 is 7. ln of E of 4x plus 3 is 4x plus 3. First one I'll demonstrate. E to the ln of 7. How do you solve? Slightly more complicated looking formula. Plus 9. Sorry, plus 7, my bad. Nine divided by 5. E to the negative x equals 9/5. Well, now we got to get that negative x off of there, so we take a natural log. And we get negative x equals natural log of 9/5. Blast it out on the calculator, we'll get x equals negative 0.5878. You can check that by putting it in 5 second E, and it's negative negative, so it's 0.5878 minus 7 should get you 2 and change. Pretty darn close. Now, which log base should we use here? Doesn't matter. We're in a natural log lesson, so let's use a natural log. But you could use any base you wanted. I could use log base 4 if I knew it on my calculator, but I don't. So I'll do natural log of 4 to the x equals natural log of 29. X equals natural log of 29, natural log of 4, natural log of 29 divided natural log of 4. Enter. We can check that because it's just 4 to that power. It should get us 29. It does. So 2.4290. So where does E show up in the real world? How about at the bank? Now here's the deal. You put $1,000 into the bank and you're getting, I'll keep the number real easy, 10% interest. Right about now your interest is about 0.01 or something insane like that. So the present value is equal to the amount you put in times 1 plus the interest rate and then this weird thing called compounding. To the n times the number of years. So here's what I mean. When does the bank calculate interest. If they just calculate at the end of the year and you take out your money after 360 days, you get no interest because they're like, well, it's still sitting there. We haven't run the math yet. Most banks don't do that. They compound it monthly. So you would probably say, okay, the amount I have now at the end of the year will be 1,000 times 1 plus 0.10 over 12 months in a year. That's what we mean by compounding monthly. To the 12 times 1 year. Blast that out on a calculator. You get $1,104.71. If they had not calculated it monthly, you would have gotten 10%, you got $1,100. So you make $4.71 extra. Big deal, you might say. Well, it makes a pretty big deal when you're putting big money in, but what if you compounded daily? Then you'd be using n equals 365. What if you compounded hourly? You'd go 365 times 24. What if you compound continuously? What the heck does that mean? Well, that's what it means. You use the value e. So let's just say, for argument's sake, and I'll pull this number down, 1104.71. This is how much I would have made if they were compounding monthly. The amount otherwise would be 1,000 times e to the 0.1 times 1. I'm blasting out on a calculator over here. I get 1105 and 17 cents. So you can see I make an additional $1 or almost in extra interest. That's what compounded continuously means. Compounded continuously is like the Earth population. There's so many people that you don't really think like, okay, there's only so many people having children and only so many extra children. It's compounded continuously. It's going through the roof. So it makes a big difference over a long period of time. If we were to calculate it at 5% for 10 years, a little bit more realistic number, we'd get e to the 0.05 times 10, and that would equal 1123 times e to the 0.05 times 10, make 1,648.72. All right. How many years will it take you to get $1,500? Well, you'd say, oh, 1,500 started with 1,000 at 0.05. By the way, it took 10 to get here. I'm going to guess 8, 9, somewhere in there, times t. Uh-oh, how do we do that? Take the natural log of both sides. You get the e vanishes. 0.05 t equals natural log of 1.5. T equals natural log over 0.5. T equals natural log of, I already forgot what I said, 1.5. 1.5 divided by 0.5. And I've made a mistake somewhere. 0.05. Natural log of 1.5 divided by 0.05. 8.11 years. 8.11 years. So I'll give you lots of application problems, stuff like this. At the same time, I want you guys to know how to solve these. So get natural log, got to get rid of it. Take it to the e power. They cancel. We get 5x equals e to the fourth. X equals e to the fourth over 5. You can blast it out in your calculator if you want. I'm going to leave my answer like that. And then these doggone inequalities. E to the power, cancel. X minus 1 has to be greater than e to the negative 2. X has to be greater than e to the negative 2 plus 1. Second, e negative 2 plus 1. 1.1353. Why'd I blast it out this time? Because I need to check this. Let's try natural log of 2 minus 1. Natural log of 1. Is that greater than negative 2? Natural log of 2. Greater than negative 2. How about natural log of 0? Yeah, I'm not going to worry about that right now. I'm out of time. So, looks like it works. That's it. Get to work.